Now, representation of graph. So, what I did yesterday, I talked about graph. It's represented by vertices, represented by edges, represented by spaces, all right, or regions, or faces, all right? So, what we're going to do today is you should be able to list the vertices, edges of a given graph, identify and list the adjacent vertex or vertices from a given graph, and finally, the main thing is to draw or sketch a graph, given the vertices and the adjacency list. All right. So yesterday, I've shown you what vertices are and what edges are. All right. Now, I have also shown you how to identify and list the adjacent vertex. Now, let's see what are the adjacency lists. So from yesterday, you should recall what are vertices, you should recall what are edges, you should recall what are faces. All right? So vertices is just basically a set of points. All right? Consists of, it's a graph, consists of a set of points. All right? This could be a location, or could be a train station, could be whatever. And that connection could be a train track, could be a passageway, could be routes, could be anything. And spaces or faces is just anything that's in between. All right? Now, adjacent and connected vertices. This is again a revision from yesterday. Two vertices are said to be adjacent if they are opposite end of one edge. So that's a edge, the edge AB. They are adjacent. All right? Between A and C, there is no edge at all. So they are not adjacent. But they are connected because A can be connected to B, A can go to B, and B can go to C. All right? So AB, adjacent, BC, they are both adjacent. All right? Whereas AC are not. But they are connected because you can go from A, B, and C. So the next definition is two vertices are connected if there exists a path connecting the vertices. Now, the set of vertices, you can write in the set notation, and V, vertex of vertices is A, B, C, D, and E. Just list that if you need to. And then the set of edges is given by AB. So AB is just naming the edges, that's all. AC, this one. AE, that one. BC, here to here. BD, and CE. There's no connection between DE, therefore you don't have to say anything. However, if there's an extra connection between BD, you must mention that as well. There should be two BDs in there. Or if there's a loop, EE, you must mention EE in there as well. All right? Or you can identify that if you're given this, you can identify all this, the vertices that are adjacent, and you must be able to draw the graph. Right? Okay? So make sure that you list all the edges. Now, adjacency list. We know that vertex A is adjacent to B, C, and E. So therefore A with a colon, B, C, and E. Now for the rest of the vertices, B is adjacent to A, C, D. A, B, okay, you can see that B is adjacent to C, B is adjacent to A, B is adjacent to D. Therefore, that's a list back. All right, C is adjacent to A, is adjacent to B, is adjacent to E. So that's how you list it. B is only adjacent to B, and E is only adjacent to A and C. So if you're given this, you should be able to draw your graph. All right? Yeah? Just you have to be able to read the adjacency list and then think about the graph. Now, the graph that you draw may not necessarily, if you're given a list here, without the graph. All right? Whatever you draw may not be the same as this. There will be slight different because you might put A, B, C, D, and E in a different way. So when you are asked to draw a graph, as long as you can interpret the list and draw the graph, it may look something different. So here, if I do it this way, C is connected to B. I know that C is connected to A. C is connected to B, C is connected to E. All right, let's start from there. A is connected to B, A is connected to C. I've already drawn that. A is connected to E. All right, B is connected to A, B is connected to C, B is connected to D. D is connected to B, so E is connected to A, E is connected to C. See, the way I draw is slightly different now. However, if you write the adjacency list, it should always be the same. All right? It doesn't matter. I mean, in the exam or test, we will actually look at how you draw it. Generally, to avoid a lot of marking, I don't think we will have a lot of us drawing of graphs. But I've seen questions before. Now, can you think about this? Can you draw a graph from the vertices and edges? All right, look at that and draw it. The first thing that I would do is just put 5 dots in, 5 points in, the 5 vertices in, and then you start thinking about how you draw it. By the way, did anyone leave a pencil case here? Yesterday? Okay. It's not from this one. Oh, by the way, Taro, forgot to wish you a happy birthday yesterday, Taro. 1 day late. So your A, B, C, D, E might be the same as me, your A, B, C, D, E might be different from me. It really doesn't matter. So start thinking about what A, B is from the list A, B, A, D, and A, E. Then you can cross C, D, C, E, and D, E.
So,
yeah.
Is there like a rule that you don't cross lines?
No, there's no rule that you don't cross line. There will be only rule that you don't cross line when you look at playing the graph, which is next week, not yet. At this stage, it doesn't matter. If you cross the line, there's nothing wrong with it. All right? I mean, if you want to draw straight lines, that's fine.
Mine is the most.
Not a big issue. As long as you identify it. All right, crossing line is fine until we come plan a graph. We will learn a little bit more about that next week. Don't worry about that. Don't worry about it yet. At this stage, if you cross a line, nothing's wrong with it. All right, you could do that. And there are many ways of doing it. Look at this. Same thing, same description. It depends when you put where you put your A, B, C, D, and E. Now, this obviously is another way of doing it. Another way, another way, another way. So there's no right or wrong answer. All right? When you do question like this, when you observe that compared to the answer in the book, just make sure that everything is connected according to the list. That's all. All right. Now I'm going to stop here.